Okay, good afternoon. So we are going to go over the practice test number 2. We're going to have 10 questions on the test, and you're going to answer 9. So you've got to study your quiz, especially the solution set that I posted for you, because 4 questions from that quiz will be given. So it's a limit and continuity. Read it carefully. See, the question will be similar to the quiz, but some of you missed some point. Make sure you are not going to miss it again on the test. So we need 6 more questions to consider, and the 6 are going to be as we have it over here, linear, linear approximation, then problem of a differential, chain rule, as is here, okay, chain rule. Then we are going to have a directional derivative, 2 questions on the directional derivative, 1 question on the tangent plane that I did here, okay? So study carefully, you should get 100% really on this test. Because when you get to the next test, the topics going to be quite different. And you're not going to see these type of topics that I do on test 2 anymore. So that's your last chance. So you better get whatever you can, okay? So this is it. Let's just go with the topic. So you study limit, continuity, partial derivatives if you like. Then this is going to be the next topics. So that's going to be test. Okay, that's it. Practice test. Okay, that's it. The practice test number 2. So the topics that you studied from your previous quiz. Okay, these are going to be 1, limit. Okay, a limit of a function, whether limit exists or does not exist. You see from your previous quiz. Okay, and continuity. Okay, continuity of functions. So, you know, the other one was domain and the range of the function. So, domain. Okay, domain, range, and graph of functions, okay? Graph of a function of several variables. So these are the topics that they are not in this test, on this practice one, that you are going to be questioned, okay? So you have to study your either your quiz or practice quiz. This number 2. So we assume that you know this part. Now we go to the next topic. The next topic is a linear approximation, okay? So this is going to be number 1. We are interested in linear approximation. Linear approximation of function. And we're mostly interested in a function of 3 variables. 2 or 3 variables, doesn't matter, okay? So the formula is this one. Basically what we're going to do, we're going to approximate the value of the function by its linearization or the tangent line. So if this is going to be 2 variables, the formula is L of xy, which is going to be for the 2 variables at the point AB, going to be f of AB plus partial of x at the AB times x minus a plus the partial of f respect to the y at AB times y minus b. That's for the function of 2 variables. And the idea is that the value of the function, okay, can be estimated by the value of its approximation. Of course, if the point x comma y is going to be close to the a and b. Okay, this is linear approximation for a function of 2 variables. Similarly, if you have a function of 3 variables, it's going to be x, y, z. So we get value of the function f of a, b, c plus partial respect to the x at the point a, b, c times x minus a, then partial respect to the y, okay, at the point a, b, c times y minus b, and partial respect to the z at the point a, b, c times z minus c. So that's going to be linearization for a function of three variables. Okay, and the result is going to be the value of the function f of x, y, z would be the same. It can be estimated by L of x, y, z. Of course, if the point is going to be very much close to the A, B, C. That's the idea of the linear approximation. So in the problem, the point would be given to you, okay? But sometimes the point won't be given to you. So you have to pick a nice one. I'm going to show you. Okay, so be prepared. So the problem is going to be in number one. Okay, what we have in number one is we want to find the linearization, find the linearization or linear approximation, linearization of function f of x, y, z equal to the x, y, z at, okay, at the point 1, 1, 1 to approximate, to estimate, to approximate, okay, to approximate this number, the value of, so the value is 0.98 times 0.99 times 1.03. Okay, you want to estimate these values using linearizations. Okay, if the point is not given to you, you just look at this one. You look at this one and you pick one yourself. Okay, the point must be a nice one. So 0.98, you estimated by 1. 0.99 by 1. 1.03 by 1. So this is going to be your job to, okay, to get the point yourself. That's it. It's a function of three variables, and you have the formula, and you go for it. You have to find the partial derivatives for these. Okay, this one, 1 by 1. Okay. This. This is it. We have the formula to take care of it. Okay. So there you are. Find the partial 1 by 1. You have the formula, and you take care of it. Okay. So there you are. We find f sub x. F sub x, you focus on x. This is going to be y, z. We find f sub y. We focus on y. X, z. We find f sub c. We focus on z. It's going to be x, y. These are the partials. Find them at the given point, 1, 1, 1. So f of x, 1, 1, 1. That give you 1. Fy at 1, 1, 1. That give you 1. And fz at 1, 1, 1. You just substitute. You get 1. Okay, that's it. Go back and substitute, and then do your estimation. Okay, this is the formula. So linearization x, y, z is going to be f of 1, 1, 1. We need f of 1, 1. Okay, f of 1, it's just 1, because you have 1, 1, 1. So there you are. You get 1 plus partial respect to the x is 1 times x minus 1. It's going to be 1 times y minus 1. It's 1 times z minus 1. That's it. You can simplify it if you like, or you can keep it as is, substitute your result. But this is easy, so I simplify it. So it's going to be simply 1 plus x minus 1 plus y minus 1 and plus z minus 1. So if you put these together, one of these 1 will disappear. So we get x plus y. Okay, we get x plus y plus z minus 2. This is going to be your linearization. Okay, any question? It's a kind of tangent plane. Now you quickly argue that the value of the function, okay? So the value of the function can be estimated. This is it. Okay. So the value of the function f of x, y, z, you know that this can be estimated by L of x, y, z, which is going to be now x plus y plus z minus 2. But of course, you know, if the point, if x, y, z is close to the 1, 1, 1. Now the point that you have is what? 0.98. Now you substitute. So f of 0.98, comma, 0.99, comma, 1.03 is going to be almost, you substitute, almost 0.98 plus 0.99 plus 1.03, okay, minus 2. Okay, this is it. If you add them together and simplify it, that gives you 3 minus 2, which is equal to 1. Okay, so we claim that this value, 0.98, 0.99, and 1.03 is going to be almost equal to 1. Okay, so the one that you are interested in, so 0.98 times 0.99 times 1.03 is almost 1. You check it with your calculator, you have to give us the calculator result. Okay, so calculator result, this is going to be the calculator. So what's going to be calculator result? 0.98 times 0.99 times 1.03. Use your calculator, that gives you 0.999, which is almost 1. So good job. You did it, okay? But the one that you're going to have, you know, it's going to be kind of a radical one, you know, rational one. That was too easy. You know, it's fine. You're interested in the idea. But, you know, it's going to be at least kind of square root type function. And we are not going to give you the point, remember. You have to pick a point, nice point yourself, okay? And that's why we have to do the second part, you know, the radical function to give you idea how we're going to pick those. Any question? So this is the way you do it, straightforward, one question. So let's do the second one. It's more a kind of a real one that we see. Okay. So what I'm going to do, I'm going to change the version of problem so you know that how you are going to pick the point yourself, okay? But it's the same thing. So that would be number 2. This is the way we usually express the problem. So that's it. We want to find the linearization, okay? And this is it. We ask you use the linearization or linear approximation. Linearization of this function, okay, of the function f of x, comma y. It may be 3 variable, but in this case, the 2 variable. It's a 9 minus x squared minus 2y squared. Okay, use the linearization of this function to estimate, to approximate okay, to approximate the value. Okay, the value of what? Of f of 91, comma 0.82. See, this is the real problem. That would be. So what you have to do, you have to find the point of estimation yourself. Okay, you just check, you see this is negative 0.91. So the number that you can have something like a negative 1. Okay, and this is a positive 1. And make sure that when you substitute over here, this must be a perfect square, because if it's not a perfect square, if you want to take the square root just using a calculator, so we can do it right away, okay? So pick a number. pick a number over here and just do it. So it's not going to be a difficult number, but we want you to guess the number yourself. Okay, so what you are going to do, you suppose the point that you are going to pick is, suppose A comma B. If it's going to be 3 variables, you have to pick A, B, C. A comma B to be a -1 and 1. Okay, you pick this point, -1 and 1. Now you do your estimation over here. So then it's a function of 2 variables. You get the x comma y. Linearization is going to be what? At this point, it's going to be f of -1 and 1 plus partial respect to the x at this point times x plus 1 minus -1 plus partial respect to the y at this point, okay, times y minus -1. Okay, you're sure that with this estimation that you'll be able to get your result. So go for the partials. Okay, this is a radical function. We switch it into the exponential function to get the partial. So I rewrite f of xy as 9 minus x squared minus 2y squared to the half. Now that would be easier to handle the partial. So the partial chain rule, f sub x is going to be equal to, you bring the half down, 1/2, 9 minus x squared minus 2y squared to the -1/2 times the u prime derivative with respect to the x, which is a -2x. A -2x, then you can simplify the 2 and -2 and rewrite this one. And so that gives you something like a -x on the top. And you have the square root of 9 minus x squared minus 2y squared. You see, this is going to be the case. Okay, that's partial at, okay, but you want it at what? You want it at the -1 and 1. So apply the -1 and 1. So f sub x at -1 and 1 would be what? X is a -1, y is positive 1. So the top would be a positive 1 when you substitute. Okay, if you like, it's a -1. Then at the bottom one, it's going to be the square root of. So that's a 9 minus x squared. If you substitute, if you find f of -1, 1 at the end, at the first, that would be better. But you know, it's the same thing. So that gives you a -1 minus 2. And so that gives you 1/6. So this is f sub x. Okay, don't have to simplify it. Keep it, do the simplification at the end. So we have to find the f sub y, differential respect to the y, very similar. It's going to be 1/2, 9 minus x squared minus 2y squared to the -1/2 times the derivative with respect to the y, -4y. Again, you can simplify one of the 2's here, so that gives me -2y. So if you rewrite it, this time you arrive at the -2y. Radical 9 minus x squared minus 2y squared. Okay, now evaluate it at the point that you are interested in. So f sub y at the -1 and 1 would be, the top would be -2y, -2 times 1, and the bottom one is like the previous one. It's radical 6. So that gives you -2 over radical 6. Okay, that's f sub y. Okay, and now the value of the function, f of 1, 1. If you substitute, you get the 1 minus 9 minus 1 minus 2. So that gives you radical 6 too. Okay, go back and write the linearization and do your estimate. Okay, there you are. L of x comma y is equal to the value of the function is radical 6. The first partial is 1 over radical 6 times x, okay, at the -1 plus 1. And this is going to be minus 2 radical 6 at y minus -1. Okay, so that would give you the result. You don't have to simplify it because you have to substitute to get those numbers, okay? So you better substitute the numbers, then simplify. I did simplify the other one because that was easy. But we don't need simplification. We just, we use the idea that this is it. So L of x comma y is the same as f of x comma y. Okay, if x comma y is going to be close to the -1. So the one that we are interested in is what? F of the given one. -0.91. -0.91 and the 0.82. So this is going to be almost like radical 6, 1 over radical 6, the difference. X is a -0.91 plus 1. And it's going to be minus 2 over radical 6. Okay. So -0.91 plus 1. This is it. Minus 2 radical 6. I'm going to work on the y minus, and the y is 1. It's going to be, I'm sorry, y is 0.98, 0.82. 0.82 minus -1. Okay, you can take care of these. So, you know, this is going to be what? This is going to be 0.9. Okay, this is going to be 0.09. 0.09, and this is going to be negative 0.18. Okay, you have to use a calculator to get these numbers. You can work it with it, you know, with this radical 6 and then do it, or just do it right away, you know. We give something nice. In this case, you know, radical 6 is not going to be kind of a nice one, but the way you are going to see it, always it's a nice number. Okay, point. That's a 0.9 over radical 6, and this is going to be negative 0.18 over radical 6. Okay, you can put them together, and eventually the calculator give you this number. Okay, that gives you 2.63. Okay, 2.63. That's going to be the estimate with the linearization. Okay, that's estimate with the linearization, but you have to confirm it with a calculator. Any question? My calculator result is just substitute. Okay, the calculator result is you are going to find what is f of negative 0.91 comma 0.82. You go to the function and you substitute it and use your calculator. Okay, remember the function is the square root of 9 minus x squared, negative 0.91 squared, minus 2y squared, 0.82 squared. Then use your calculator. I have, check it with your calculator. I have 2.612, which is almost the same. Okay, so be prepared for it. But that you have to pick the number yourself, the point estimation that you're going to have. Okay, so pick number which is going to be close to those decimal values. Okay, and it would be a nice one. It may be 3 with the 3 variables. You may have x, y, z. It's going to be the same. Any question? So the function is going to be something like, you know, the square root type function for the quiz. So we're just checking the partial derivatives to make sure that you can handle it. Okay. So that is topic number 1. Any question? We need 6 questions besides your quiz. This is the first one. linearization. Okay. The next one, the idea of the differential is easy problem. Okay, you may see the differential directly, or you may see it indirectly in the problem. So just check it and just make sure you know it. Okay, so going to the next topic for the next question. So this is question number 3 over here. So the topic is what is differential. Okay, differential. And you know that the definition of the differential is going to be a function of two variables. And differential of the z is partial derivative of f respect to the x times dx, partial derivative with respect to the y times d. That's differential of the c. If the function is function of three variables, f of x, y, z, differential of the w is partial respect to the x times dx plus partial respect to the y times dy plus partial respect to the z times dz. This is all we need. Okay, usually give you two and you check either one. Okay, so the one that you have is this, and the first part, the function is f of x comma y, which is equal to the x squared plus 3xy minus y squared. Can do it right away. Just get the derivative. So you may call this one z or the df, it doesn't matter. Okay, so the differential of this function, differential of the z, if you like, is going to be partial of f. I write it down, f sub x dx plus f sub y y, partial respect to the x to the y, equal to, open up the parentheses and get the partial. To focus on x, the root of x squared would be 2x. Root of the 3x would be 3, so we get the 3y. This would be 0. So times that by differential of the x plus. Focus on y. This would be 0. Root of y is 3y, so that gives you 3x. Focus on y, 2y. Differential of the y. Done. Any question? So that's a differential of this function, the function of two variables. So we are going to have a three variable. You don't have it over here, but you may be given three variables. So we have only two variables, okay? So this is it. It's a 2x sine of y, okay, minus 3x squared, x squared, y squared. This is the one. Again, it's a function of two variables, so differential of the z is equal to the partial of f respect to the x dx, partial of y respect to the y dy. To differentiate, focus on x. So the derivative would just 2x, 2 sine y, minus derivative with respect to the x, 2 times 3, 6, 6xy squared. dx. Okay, plus derivative with respect to y, focus on y. If I have sine y, cosine y. So that give it 2x cosine y minus derivative with respect to the y. 3 times 2, 6. 6x squared y. That partial of the y. That's it. Any question? You don't have any of the three variables, I give you one. So let's have another part, part C. The part C, let's say the function is w is equal to the x e to the, okay, e to the y z. We want to find the differential of this function. Okay, it doesn't matter. We have three variables, that's fine. So the differential of the w is partial respect to the x times dx, partial respect to the y times dy, and the partial respect to the z times dz. Now differentiate. is going to be equal to the first one, respect to the x. Only the second one won't have any x. So we're just focusing on x. Derivative of x is 1. 1 times e to the yz. So e to the yz times dx plus derivative with respect to y. This x stay the same. Exponential function never change. Okay. And you have to multiply by u prime. U prime derivative of the top. Derivative of the top respect to the y would be just z. So it's a x z e to the yz times d. Okay, I repeat it again. Derivative with respect to the y, there is no y here, so x stay as is. Exponential function never change. And derivative of the top respect to the y would be z. So x z e to the yz. Okay, plus the last one respect to the z. Again, x stay as is. Exponential function never changed. The top derivative respect to the z would be y. So x y e to the yz and dz. So that gives you differential of a function of 3 variables. Any question? So this is how we check differential. Very important. Okay, important concept. So that is going to be the case. Okay, the next question, of course, going to be chain rule. Okay, we just give you one format. We just put 2 over here, but we just give you 1. But mostly we are interested in the chain rule for a function of 3 variables. Remember, it's a kind of differential, but for the composition of 2 functions. So this is going to be the idea of this question. Third question, chain rule. Okay, that's it. Chain rule. Chain rule formula. Usually give you a function of 3 variables and we make it a specific at one specific point. Okay, and so these are the 2 possibilities with function of 2 variables and 3, but we usually interested in the 3 really. But in number 4 we have the 2. So this is it. This is number 4. Given that, okay, given that these are the function. You have f of x comma y, a function of 2 variables, x squared y plus, okay, 3x y to the 4. This is your function of x and y. But x and the y are the function of another variable. X is the sine of the 2t. And the y is cosine of the t. Okay, so you have your function is a function. This is easy chain rule. Okay, that's a mild one because you just, the last variable is just t, one variable. Okay, so they ask you to find. So we'd like to find round f, round t. Okay, at t equal to the 0. T equal to, that's it. That's easy, guys. We are interested in the second one. And so since they ask it at t equal to 0, you better substitute first, find the x and the y first. That make it easy. You need them. Okay, so the solution is going to be, since they localize it, say that, see you put the t equal to 0 into the x and the y. This is it. If you put it into the x, x would be sine of the 0, which is 0. Okay, because t is 0. And then you have the y. Y would be cosine of the 0. Okay, cosine of the 0, which is 1. So you make a note that your x is 0 and your y is 1. Now we go to we differentiate. Any question? So t0, x0, y1. F is a function of x and the y, but x and the y are a function of t. So just easy format. Okay, so what's the formula? Round f, round t is equal to F is a function of X. So you operate X first. Run F, run X. And X is a function of T. Run X, run T. You can go with the dx dt in this case too, but you know, both of them are the same. Plus, you repeat it again. F is a function of Y. Run F, run Y. And Y is a function of T. That's it. Substitute, simplify. You can do it separately or just, this is easy. We can do it as is. Okay, there you are. Run F, run X. So derivative of F respect to the X is your function. Focus on X. Derivative of X would be 2x squared. So it's going to be 2xy. Derivative respect to the X with just 3y to the 4th. That is run F, run X times run X, run T. This is it. You have a sine cosine of the 2t, but you have to multiply by u prime, which is 2. So it's going to be 2 cosine of the 2t. Okay, that is going to be the first one. Any question? Plus? Want to finish it here. Okay, plus the second part, derivative with respect to the y, focus on y. So that give you what? That give you x squared. Derivative of y, 3 times 4, 12. 12xy cubed. Times that by derivative of y respect to the t. Just a negative sign t. Negative sign t. That's it. Now you are going to evaluate that when t is equal to the 0. We know that t equal to the 0, x would be 0, and y is 1. So I just do it here. So run F, run T. We want to find it at t equal to the 0. T equal to the 0, that gives you x equal to the 0 and y equal to 1. Okay, this is it. So this would be equal to. See in the first part, 2xy would be 0 because the x is 0. 3y to the 4th would be just 3. So that gives you 0 plus 3 times the cosine of 0. Cosine of 0 is 1. So that gives you 2. It's the first part. Plus the second one would be automatically 0 because the sine of 0 is 0. So the result is 6. Okay, so the partial of f respect to the partial of f respect to the t at t equal to the 0 is simply 0. Okay, don't wait for at the end. Some people, they do all those, you know, they stay with the variables. At the end, they want to go back and substitute. Just substitute as soon as you can. Okay, because that's why they give you the numbers. They give you the numbers to do it. Okay, that's a kind of warm-up. The one that we are going to be interested in is a function of 3 variables. Next one. Okay, any question? So the next one, it's a very similar one, but your x and the y are going to be a function of 2 variables or 3 variables. Okay, so let's check there. This would be number 4, number 5. So for the chain rule, the good candidate is 5 really, rather than the 4. Okay, so what is the number 5? Number 5, if we have this function, 5. So this is given. Given that what? The function is f of x, comma y, comma z is equal to, it's x squared y plus 3xy to the 4th. That's a function. Oh, I'm sorry, I made a mistake. I did the last one. I'm sorry. I just the function is this one. I corrected. Function is x to the 4th y plus y squared z cubed. That's a function. Okay, it's a function of 3 variables. Then your x is X is a function of u, v, and w. U, v, e to the w. Then your y is u, v squared, e to the negative w. And your z is u squared, v sine of w. Okay, so f is a function of three variables, and x, y, z are a function of three variables too. So what you want to do, you want to find one of these derivatives. Okay, we are interested in this, evaluate. There are three possibilities. We should check one of them. It's given to us, round f, round v. They can ask you for round f, round u, v, or w. Okay, so you are required to do one of them. Evaluate this one at the point. This is the point. U, v, w is equal to the 2, 1, 0. Okay, that's a question. Again, you better get those substitution as quickly as possible. So you have the u, v, w. First thing to do is substitute to get the corresponding values for the x, y, z. Don't wait. Okay, find those numbers first, and as soon as you get the chance, you substitute. Okay, there you are. So I'm going to use these. I'm going to use u equal to 2, v equal to 1, and w equal to 0 in the x, y, z. So I'm going to use it here. So x is equal to, u is 2, v is 1, w is 0, so e to the 0. E to the 0 is 1. So that gives you 2 times 1, which is 2. So x is 2. Okay? So similarly, get the y. Y is, this is y. U, it's 2. V is square, 1 square. E to the negative w, again, e to the 0. So that gives you 2 again, because e to the 0 is 1. Okay, then we have z. Z equal to the u squared v. U is 2, 2 squared. V is 1, sine of the w. Sine of w is sine of 0. Sine of 0 is 0. So that gives you 2 times 0 is equal to the 0. There you are. So x is 2. Okay, so there you are. X equal to 2, y equal to 2, z equal to the 0. So these are going to be the values that we are going to use to evaluate the derivative. Okay, question? Now we go for it. What do you want? Round f, round v. Get the formula first. Round f, round v. Chain rule. Do each variable one by one. F is a function of x, so it's a round f, round x. But x is a function of v. Round x, round v, plus, it's a differential, so adding the second variable. Round f, round y. And y is a function of v, plus round f, round z, and z is a function of v. See, this would be the formula. Composition of two functions. Okay, let's do it. So it's going to be equal to derivative respect to the x of the original function. Okay, this is original function. Okay, this is what I'm going to do. Focus on x first. Okay, so this is it. That gives me 4x cubed y. And the second one, there is no x. So that's going to be 4x cubed y. Okay. At times that by x respect to the v. Okay, this is x. Okay, this is x. X respect to the v would be 2, would be just v is 1. So ue to the w. So it's going to be ue to the w. That's the first one, and just continue. Second one, derivative with respect to the y. The first one would be x to the 4th plus 2y is z cubed. Okay, that's the second one. So times that by derivative of y respect to the v. Y respect to the v, you see this is y. Y respect to the v would be 2v. So 2uv. So it's going to be 2uv. Okay, that's it. 2uv e to the negative w. So that's going to be the second part. Now, respect to the z. The first point, you don't have any z. The second part, we have z cubed, so it's going to be 3y squared, z squared, times that by derivative of z respect to the v. zv. This is z. Okay, zv, derivative of v would be 1. So that gives u squared, sine of the w. U squared, sine of w. Okay, so that would be the derivative. Now we have to evaluate it at those points that we talked about. Okay, you have the points, you see two collection of points. Substitute, this is it. The point, so this is going to be equal to the first one, equal to the 4x cubed, x is 2, 4 times 2 cubed, y is 2, times u e to the w, u is 2, e to the w is 0. So that would be the first step. Okay, continue, plus x to the 4th, x is 2, so 2 to the 4th, plus 2y, 2 times 2, z cubed, z is 0, so that would be disappear. Okay, times 2uv, 2, u is 2, v is 1, e to the w, e to the 0. Okay, that's the second part. The third part would be 0 because the z is 0. Okay, z is 0, so everything would be 0. We don't have to worry about this one. So this is going to be equal to 2 cubed would be 8 times 4, 32, 64. And this is 64 times 2, 128. Okay, so that gives 128. Okay, so that would be 128 that we have. Okay, so what else? For the second part, this would be 0, so we get only 2 to the 4th, which is 16 times. And over here, we get 4 plus 0. So that's a 128 plus 64. Okay, 128 plus 64, 192. So that would be the final answer, 192. Okay, so just be patient and just check this one. Substitute as soon as it's possible. Don't try to some people they go on simplifying first. No, substitute the numbers, then simplify it to get these ideas. Okay, so that's a question on the chain. So we give one chain. Okay, that's number 5. Number 6, this is just the application, just some rules, some equation. Okay, you may not see any kind of proof of this type of equation on the test, but it's in your book. I just want to see it. This is an idea, a formula that we usually use in application in physics. Call it the Laplacian. Okay, they ask you just to, we give you something to find its partial derivatives. So just make sure you know it. Show that the function. Okay, because you have some in your book, so that's why I just put it here. Show that the function satisfy. Okay, satisfy Laplace equation. You've taken the course in differential equation. We're going to use this type of ideas. This is it, uxx plus uyy equal to the zero. That's it. In physics, if a function of two variables satisfies this condition, that function is called harmonic function. It's going to be harmonic function, and we go with the function of complex variables in application. So there is going to be a relationship with this type of ideas. You see any complex numbers would be denoted by a plus bi. If you get a complex function, is a and the b would be changed to the function of two variables. So one of them would be u, the other one would be v. So it would be u plus iv. There is a formula in between. So that's it. But your job basically is just understanding of the second derivative. That is the idea, okay? So all of them are easy. So the first one is u e to the x sine of y. Okay, that's it. That's the first part. Just find it, add them together, show that this is equal to the zero. Say Laplacian of this function is equal to the zero. Okay, uxx, you know that. It's going to be u sub x, partial respect to the x. You focus on x, the derivative of e to the x never change. So that gives you uxx. Do it again, xx, second partial derivatives. Okay, that gives you e to the x again, sine y. That's a uxx. Okay, do it for the y, uy. You differentiate sine of y, which is cosine of y. Okay, you do it again. So you focus on the cosine. The double cosine is a negative sign. So negative e to the x sine of y. That's it. Add this together, you get the zero. Okay, so uxx plus uyy. It's e to the x sine y minus e to the x sine y, which is zero. Okay, that's it. And there is a way, this is u, then it's going to be u plus iv. There is a way that we can find that second part, okay, the v. You know, at the end of this course, we are going to have something we call it conservative force, and then you will get this type of ideas, okay, but not now. It's just practicing. Okay, so not a big deal. Only the last one is tricky. I do the second part too bad, don't expect them. See, this is very easy, a polynomial type. Same thing, u sub x, and derivative respect to the x would be 5y. uxx, there is no x, so this is 0. Okay, uy, you focus on y, that give you 5x, so uyy is 0. So it's clear that Laplacian is 0, okay? Done. But this problem is only the last part. In the problem, it's the last part. You can see this one all over the places when we argue about the Laplacian. Tan inverse of y over x. We want to prove that this is a harmonic function. Okay, remember the derivative of the tan inverse is 1 over 1 plus x squared. If it's going to be u, it's going to be u prime over 1 plus u squared. Okay, just to remind you that derivative of the tan inverse of u, for example, is u prime over 1 plus u squared. You need this formula to be able to do it, but you did it in a partial form. So u sub x is equal to derivative with respect to the x. Get this one. This is going to be the bottom one is going to be 1 plus y over x all squared. Now the top derivative with respect to the x of y over x. It's like 1 over x, negative 1 over x squared or negative y over x squared. Okay, even if you use the quotient rule, of the top bottom will be 0, bottom top it's just a negative 1. You have to simplify it. It's going to be negative y over x squared and this is going to be 1 plus y squared x squared. You multiply the top and the bottom by x squared, the top would be negative y, the bottom one would be x squared plus y squared. It's the way you simplify it. Okay, any question? I multiply the top and the bottom by x squared to remove those denominators. So that's ux. You have to do it again. uxx. uxx, again, if you want to use quotient rule, you have the top bottom would be 0, okay, because of the y. Now the bottom top. So this is going to be kind of 0 minus the derivative of the bottom is respect to the x is 2x times top, which is a negative y, divided by the bottom square, x squared plus y squared, all squared. So we multiply the top together, so that gives you 2xy. This is going to be x squared plus y squared, all squared. That's a second derivative of u respect to this. Any question? The y is very similar. There is only a difference. It's going to be just one negative sign. So if you repeat it again, but this respect to the y. So this is going to be 1 plus u squared, tangent inverse would be the same, but the top is going to be different. With respect to the y, is just 1 over x. You see? Now, simplify is 1 over x, 1 plus y squared over x squared. Multiply the top and the bottom by x squared, the top would be x. The bottom one would be x squared plus y squared. That's the derivative with respect to the y. Question? Do it again. y. Quotient. Derivative of the top bottom would be 0 with respect to the y. Now the bottom top. So 0 minus. With respect to the y would be 2y times top, 2yx. The bottom one would be x squared plus y squared. So this is negative 2xy. X squared plus y squared, all squared. Look at these two. This is 1 and this is 2. If you add them together, you get 0. Because everything is the same except the negative sign. Okay, so there you are. uxx plus uyy. It's a 2xy, x squared plus y squared squared minus 2xy over x squared plus y squared squared, which is 0. So this is the most popular one. This is just for your information to see how these connected together. Just proving something using these ideas. Okay. So this is it. You have another one with the partial derivative. Let's do that one too. So we see one of them. Okay, we want to see how you read these formulas. Okay. So any question? So just working on the partial derivatives. That is it. Remember, we talked about it when you do the second partial derivatives, the order was not important if you're dealing with a continuous function. It's the same for this number 7. Okay, this is number 7. And what we want to prove is this one. We want to prove number 7. We want to prove this mixed derivative. See f x y y y x y y y x. For this function, all of them are the same. It must be the same because the function is polynomial. Check one of the. That's a number 7. Show that. Okay, show that these mixed partial derivatives. That the mixed partial derivatives. Say f x y y, f yxy and f yyx are the same. Okay, are equal, okay, for this function. The function is f of x comma y, function of two variables, x to the fifth plus 4x cubed y minus 5xy squared. So that's the one. You have to follow the order as it's given to you. We know that the order are not important, but you want to prove that they are not important. This is the way you look at it. You see, you want to do f sub x, y, y. This is the order. You do f of x first, then you do the y, and then you do the y. This is the order. 1, 2, 2, if you like. Okay, f sub x. F sub x, focus on x, so that give you 5x to the fourth. F of x would be 12x squared y minus respect to the x, 5y squared. That's fx. Now you do it respect to the y. F sub x, then the y. Respect to the y, this will disappear. With respect to the y with just 1, 12x squared. Respect to the y, that give you 10y. That's respect to the y. Okay, now you do the y again. That was y, another y. This is 0. Respect to the y, that give you negative 10. So fx y is negative 10. That's the first one. Any question? So go back and do the same thing, but the order is different. Already, the next one. Next one, you want to try fyxy. So it's f of y first, then x, then y. In this order. Okay, respect to the y. Respect to the y, your function. Okay, that's a function. Focus on the y. This would be 0. This is 1 for x cubed minus 10xy. Okay. So this is going to be respect to the y. For x cubed minus 10xy. That's respect to the y. Okay, now you respect to the x. You differentiate respect to the x, that give you 12x cubed. Respect to the x, that give you negative 10y. Okay, now respect to the y again. So it's going to be fyx, then y. That give you negative 10. So you prove that fyxy is negative 10. Okay, any question? So the last part, you have to do all of them, okay? Because you want to prove that they are equal. If it was just randomly, you know that you just do one of them. So the last one is f of yyx. So fy first, then another y, then another x. Okay, so there you are, respect to the y first. We already got this one from the previous part. Okay, that's a 4x cubed minus 10xy. You do it respect to the y again. Focus on the y, that gives you negative 10x. And then if you do it respect to the x, that gives you negative 10. Here you are. We prove that all of them are the same. So f of yyx is also negative 10. Okay, so we confirm that you can do it as you like. F, x, y, y. These are all the possibilities having these three numbers. Okay, so there are, all of them are going to be the same thing. So we just give you something, to practice. Okay, I give a break now because we get to the main one, because this is directional derivative, gradient, and the tangent plane. Three famous problems. We give all the three. Okay, from this part. Short break, come back. Okay, so we are going to continue to the next topic. Okay, that's we talk about the equation of a tangent plane. Okay, especially we discovered the other day if you have a function of 3 variables. Okay, so in order to write the equation of the plane, you need a normal vector and a point. We proved that the normal vector can be the gradient vector. Okay, the gradient vector with the partial. Okay, the vector whose components are going to be just fix this one first. Okay. Let's see. Okay, so we are going to see what's going to be the equation of a tangent plane. So that's going to be our argument. So just remind you, number 8, equation of the tangent plane. So the idea is going to be we need a point. So the point would be given to, which is going to be x0, y0, z0. Then we need a normal vector. Your normal vector is going to be gradient vector, which is going to be f sub x, f sub y, f sub z, mostly the function of 3 variables. Okay, that's going to be the one. So this would be your normal vector, which is a, b, c. If you have it, then your equation would be simply what? Your equation would be a times x minus x0 plus b times y minus y0 plus c times z minus z0 equal to 0. And then you simplify it. Okay, so that would be the idea. So your function representation may be in 2 different formats. Directly would be given to explicit function or implicit one. So this is going to be the case, okay? So the first part, the function, okay, so basically you want to find the equation of this is the problem, okay? You want to find the equation of it's number 8, equation of a tangent plane, and find the symmetric equation of the normal line to the surface of the given point. Okay, so the first part, it's a z equal to this the function y e to the 2xy at the point is 0, 2, 2. Get these function. Okay. So the way we did it the other day, we are going to write this one and move everything to one side of the equation to have a general format. that we talk about it. So the solution is going to be z minus y e to the 2xy is equal to the 0. Okay, so this is going to be the function that you're going to call f of, okay, so your f of x, y, z is simply z minus y e to the 2xy. It's the way you introduce the function, okay? You can do this one directly, but this is the way we do it. So there you are. Quickly find those gradient, okay? Find the partial derivatives at this point. So I go with the f sub x first. You focus on x. If you focus on x, this would be 0. There's no x here, so just the exponential part minus, you get the y, e function is the e function, but you have to multiply by u prime. What is the u prime? Root of the top respect to the x, which is going to be 2y. Okay, so that gives you negative 2y squared e to the 2xy. Any question? You have to be careful, double check to find this derivative all right. With respect to the x, this would be 0, and negative y is the coefficient, e function is the e function, but you have to find the derivative with respect to the x, which is a 2y. Then you have to evaluate at that given point, okay? So evaluate it at this point. So we want to find fx of 0, okay, 0, 2, 2. So x is 0, y is 2, z is 2. Substitute, it's going to be negative 2 times 2 squared, e to the, okay, e to the, your x is 0. Since x is 0, it's going to be e to the 0. So that gives you negative 8. So this would be f sub x. Any question? X is 0. So e to the 0 is 1. 4 times negative 2, negative 8. So that's f sub x. You go for the f sub y. Go back into your function, find the partial derivatives. It is your function partial respect to the y. This would be 0 again. You have y in 2 terms, so you have to use the product rule. Derivative of the first times second, second first. Derivative of the first would just negative 1, so that gives negative e to the 2xy. Plus the derivative of the second times first. So a derivative of the second one respect to the y. So it's going to be plus derivative of the second one, e function is going to be e function. You have to multiply u prime. Derivative respect to the y would be 2x. So it's a 2x e to the 2xy. Okay. This is derivative of this exponential function. Okay, respect to the y, but you have to multiply by the first, which is a negative. Okay, since both function got the y, you have to apply the product of the first, second, first. And now evaluate it. You can simplify it or just evaluate it right away. So I'm going to evaluate it at 0, 2, 2, x0, y2, z2. Okay, this is it. If you put it here, that gives you negative x is 0, so that gives you e to the 0. And since x is 0, everything would be 0. Okay, it's going to be 2 times 0. So you don't have to continue because the second part would be 0 right away. Okay, and e to the 0 is 1, so the result would be a negative 1. Okay, so that gives you negative 1 right away. Okay, so there you are. We continue. So we need to do the z. Okay, we go for the f sub z. So what is going to be f z? That's easy. Partial respect to the z. Partial respect to the z would be just 1. The rest, there is no z here. So it would be 1. So even if you find it at that point, which is the 0, 2, 2, it's going to be 1. So there you are. So your normal vector is going to be f sub x and negative 8. Okay, f sub y is a -1, and f sub b is 1. Okay, so that would give you your normal vector. Okay, now we put them together. So this is the normal vector, which is ABC, and this is the point. What is the point? The point is 0, 2, 2. Okay, so this is your ABC, and this is your x0, y0, z0. So we are ready to give you the equation. Any question? Equation of the plane a times a is -8. So -8 times x minus x0. x0 is 0. Plus b minus 1 times y minus y0, which is -2. Okay, plus c is 1. 1 times z minus z0, which is 2, equal to the 0. You have to simplify it. So that gives you a -8x. You apply this negative sign inside, it's going to be -y plus 2. Okay, so this is going to be the case. Okay, and the last part would be z minus 2 equal to the 0. That's it, these two would simplify. So basically you are going to have a z minus 8x minus y equal to the 0. So that gives you the equation of the, okay, that gives you the equation of the thing, and be done. Okay, any question? So just do it step by step to get this one through. We are not done. This is the equation of the, this is tangent plane. Tangent plane. The bonus is they ask for the normal line. Remember, for the normal line, it's just symmetric equation of the line. So what's going to be normal line? You have your vector, which is ABC. So normal line would be x minus x0 divided by a equal to the 1 minus y0 divided by b equal to the z minus z0 divided by c. And you already got all this information. Because your x is 0, x minus 0 over a is -8. Okay, it's equal to the y minus 2. Your b is a -1 equal to the z minus z0, 2 over f sub 0, which is 1. So this is going to be the equation of the. Okay, so the main one is you must know that the gradient vector is your normal vector. That's all you need. Okay, so that would be the first one. So make sure to pull everything to one side of the equation at the beginning. You have to make a function, okay, yourself. You have to make a function, then get those partial of those functions, okay? So that is number part 1. Okay, we have another one. Part 2 is kind of a sphere level. Okay, that's it. X squared, y squared, z squared equal to the 9 at 1, 2, 2. Same thing, pull everything to one side, make it a function, and just go for it. Okay, so that would be 8b. Surface is this one, x squared plus y squared, z squared equal to 9. Put it at the point. Okay, at the point. The point is 1, 2, 2. So same thing. You create your. Okay, you create your function first. So move everything to one side. X squared, y squared, z squared minus 9 equal to the 0. This would be your function. Okay, so the function of f of x, y, z is equal to the x squared plus y squared plus z squared minus that. See, the functions are implicitly defined. You don't have the z equal to. If you have the z, it would be easier. Okay, so that's it. Same thing. Find the partials and evaluate. That's easy because the partial respect to the x would be simply 2x. This is easy. Let's have at the same time. It's a 2y and f sub z is a 2z. Quickly evaluate it at the given point, 1, 2, 2. So f of x at 1, 2, 2. X is 1. So that gives it 2 times 1, which is 2. Okay. Then the f sub y at 1, 2, 2 is a 2y, y is 2. So that gives you 4. Okay, then f sub z at 1, 2, 2. It's a 2z, z is 2, 2 times 2, which is 4. There you are. So we have the normal vector right. So the normal vector is going to be 2, 4, 4, which is going to be A, B, C for the. Okay, that's a normal vector. Okay, and you have a point. Point P is 1, 2, 2. So this is going to be your x0, y0, z0. So equation A times 2 times x minus x0. 2 times x minus 1. Okay, that's going to be plus B4 times the y minus y0, negative 2. And plus C is 4 times. Okay, z minus 2. Z minus 2 equal to the 0. That's it. You can divide all of them by 2, simplify it. You see, you get a chance over here, just do it. Or you can leave it, but you have to do it at the end. So this would be just simply x minus 1 multiplied 2 inside. You have to simplify. That give you 2z minus 4 equal to this. So that gives us x plus 2y plus 2z, and the numbers minus 9. So that gives you equation of a tangent. So that's going to be tangent. Any question? The bonus, normal line. Okay, so normal line. X minus x0. X0 was the point. X minus 1 over A, which is 2. Y minus y0 is 2. And B is 4. Z minus 0.2. 1, 4. So that gives you the equation of the normal line, and you're done. Okay. So again, the key is knowing the normal vector. How we're going to find it. Okay, so that would give us the equation of a tangent. Any question? And we have 2 questions on the directional derivative. One of them is evaluated. The other one is it may give you maximum rate of change. You must know it how to use them together. You get the maximum rate of change and the direction. Okay, so this is it. Let's remind you for number 9. A directional derivative. Directional derivative. Remember, derivative, the formula is directional derivative of the function in the direction of a unit vector u is gradient f dot u. But make sure you know that u is unit vector, a unit vector. Okay, and the gradient is simply f sub x, f sub y, f sub z. That's it. If you don't like this formula, you can write down in, in expanded form right away. We don't mind. Okay, if you don't like it, this is without the notation of the gradient. F sub x u1, f sub y u2, f sub z u2. Okay, so this is going to be directional derivative. If it's going to be a function of two variables, you don't have any z. So we have a couple of them over here. Be patient, substitute to get the numbers. It can be two variables or the three variables, okay? And so the first case is this one. The function is a function of two variables. F of x, y is equal to 3x to the fourth minus 5y squared. You need a point. The point is given to you. Is a 1 and negative 2. And you need a vector. Vector is given is a 5 over 13, comma, negative 12 over 13. That's it. First thing to check, make sure that this vector is a unit vector. If it's not, you have to normalize it. Okay, so find the norm of this vector first to check to see that you are okay. Okay, so there you are, finding the norm of v squared. The square of the terms 5 over 13 squared plus a negative 12 over 13 squared. So 5 squared 25 over 169. That's 144 over 169. It's going to be 169 over 169, which is 1. That's fine. So V is, okay, V is a unit vector. Okay, check it. So in this case, it's a function of two variables. So this is it. The way we can write it down is, so the directional derivative of f would be partial respect to the x times u1 plus partial respect to the y times u2. This is your formula. Just go for it. Easy function. Okay, partial respect to the x. Focus on x, 12x cubed. Partial respect to the y, focus on y, negative 10y. Find it at the given point. Okay, some people, they do it, then they ask for the given point, so just do it. And it's right away. Okay, the point is 1 and negative 2. So it's going to be f of x at 1 and negative 2. x1, so that gives you 12 times 1 cubed. It's 12. Okay, that's it. Go for the f of y at 1, negative 2. This is your partial with respect to the y, 10y. Y is negative 2, so negative 10 times negative 2, which is a positive 20. That's it. So go for it and remind yourself that the v is 513 and the negative 1213. And this is your u1 and u2. Okay, so the partial derivative would be f sub x, which is 12, times the u1, 5 over 13. Okay, 5 over 13. Then it's going to be plus partial respect to the y, 20, times u2, negative 12 over 13. That's it. You better multiply it because keep this denominator, you'll be able to add them together. Then simplify it at the end. So that's going to be 60 over 13, and that would be minus 240 over 13. Okay, so that gives you negative 180 over 30, and you're done. Remember, the result must be a number, not a vector. So the partial, this is it. Directional derivative at the point 1 and -2 is going to be -180 over 30. And you're done. Okay, you don't have to simplify it because this is going to be the result. Okay, just check to see the one that I gave you is, yeah, it's the same one. Any question? So it's a function of two variables, but mostly, you know, expect a three variable one. It's just this one question. So we usually give you three variables, okay? So this is it. You have another two variables. We can check that one quickly too. Then go to the, okay, the three variable, which is the one that we are going to be interested in, okay? So two variable, the second one is just want to make sure to get the derivative all right. Okay, so that's the first part. And the second part is this function. Same thing. Okay. So the function is f of x comma y. The square root function, x squared plus y squared, wanted at the point P, 4, and the V. The point is the vector that you have to normalize it. This is the difference between the previous one and this one. Make sure to do it. Okay, first check the vector. So we check the norm of the V, which is going to be 4 squared plus -3 squared. So that makes it to the 16 plus 9, which is 25. Okay, that's a norm square, of course. So this means a norm of the V is 5. Okay, so V is not a unit vector. A unit vector. So normalize it. Normalize V. So you must do it automatically yourself. Okay, normalizing means you introduce the U to be V divided by the norm of the V. But the norm of the V is 5. So that gives you a fifth of V. Fifth of V. 4 and -3. So that gives you 4/5 and the -3/5. So you have to use this one. U equal to 4/5, comma, -3/5. So this is going to be your U1 and the U2. So make sure you do it. The formula can use only if you have a unit vector. Okay, any question? Now we go for the partial evaluation and come back and do it. So the function, you have to rewrite it as x squared plus y squared to the half. And then find the partial derivatives using the chain rule, of course. Okay, f sub x. Chain rule, 1/2 x squared plus y squared to the -half. You prime. Derivative respect to the x, 2x. You simplify the 2 and 2, rewrite it as x over radical x squared plus y squared. That's partial respect to the x. Quickly evaluate it at the point which is a -3 and 4. Okay, so the partial at -3 and 4, x -3, so that gives you -3 on the top. The bottom, x squared plus y squared, x squared 9, y squared 16. So -3 over radical 25, which is going to be -3/5. So that gives you partial respect to the x. Okay, question? Repeat it again, the y is going to be very much similar. So f sub y, derivative would be y over radical. Everything is the same. So that gives you your derivative. And now you find it at fy at -3 and 4. That simply give you y is 4/5. Okay, that's it. Now we are ready to give you the partial directional derivative. So directional derivative of f at the point in -3 and 4 in the direction of the u is equal to partial of f respect to the x, which is a -3/5, times the u1. u1 is 4/5, plus partial derivative respect to the y, which is a 4/5, times the u2. u2 is -3/5. -3/5. Simplify, you multiply first, so that give you -12 over 25. Okay, minus 7, sorry, minus 12. It's the same thing, okay? 25. So that give you -24 over 25. So that give you the direction of the derivative. Remember, it's a number. And then that. Okay, so again, the difference between the first part and this, the next part was normalizing the vector. Have to do it automatically. Okay, any question? Let's check the part C. This is the one that mostly are going to be interested in the three variables. Okay, so partial x, partial y, partial z. Okay, so that is going to be the third one. We're going to check. Okay, that's it. X sine y cosine z, p 3/4 -π/2, b I minus 2j plus 3. So we're going to check this one. Okay, so this is going to be 8. It's a 9c. Okay, for the 9c, the function is g function, x, y, z. The g is x sine of y, cosine of z. At the point P, which is 3/4 x, y, z, and the -π/2 in the direction of the vector v, which is I minus 2j plus 3k. We rewrite it as 1, -2, and 3. That's it. Partial derivative, quickly check the v, which is not a unit vector. Okay, make sure you check it. So we're going to check the norm of the v, or the norm square first. Okay, 1 squared, -2 squared, and the 3 squared. So 1, 4, 9 is 14. So v is not a unit vector. It's not a unit vector. Quickly normalize it. We normalize v. So you introduce the u to be equal to the v over e. Okay, what's a norm? I'm sorry, the norm would be what? Norm of v would be radical 14. Okay, because norm square is 14. That's correct, yes, 4, 5. Yeah, that's 14. So this is going to be v over radical, okay, radical 14, or 1 over radical 14 times the v, which is 1, -2, and 3. You multiply inside because you need the v1, v2, v3, u1. So that gives you 1 over radical 14, -2 over radical 14, and the 3 over radical 14. You don't have to know rationalize it, keep it as is. So this would be u1, u2, u3 this time. Okay, so this is simply U1, U2, U3. Now we go with the partials. We know that we have to find the partials at the point. So this is your function. Okay, this is going to be the function. I want to find the partial derivatives with respect to the x. It would be 1. With respect to y, you change this one to the cosine of y. With respect to the z, that would be negative sine z. Okay, so let's go for it. This is it. G sub x simply would be sine y cosine z. Okay, G sub y would be x cosine y cosine z, because it's a product. Okay, G sub z. If I have a cosine, it's a negative, so it's going to be negative x sine y sine z. This is your 3 partials. You want to find them at the p 3 pi 4 negative pi 2. So let's do it. G sub x at 3 pi 4 at the negative pi half. Okay, so x is, we need the y and the z. And so that the y is pi 4, so that gives sine of the pi 4 at the cosine of negative pi half. You know that the cosine of the negative pi half or the pi half is 0. So that make it into the 0. That's first one. Okay, nice. Then you find the g of y at 3 pi 4 negative pi half. Okay, then we go to that part to substitute. So that's a gy. This would be also 0 because of the cosine of the z. To get these numbers. Okay, let's continue to get it done. So this would be 0 as well. Okay, because of the cosine of the z. So that gives you 0. Okay. See. Okay, so that would be, so the gy is 0. Okay, because of the cosine of the pi half. Then we get the gz. Because of the gz, you have all of them here. So we have a negative x, which is going to be negative 3 times the sine of the pi 4 times the sine of the negative pi half. So sine of the pi 4 would be radical 2 over 2. So that gives you a negative 3 radical 2 over 2, and the sine of the negative pi half would be negative 1. So that gives you negative radical 2 over 2. So these are going to be 3 numbers that you have. Okay, the first 2 is 0, which is nice.
Is it positive 3 radical 2 over 2?
Why positive?
I think you're missing a negative.
Oh, yes.
Okay.
You are right. Thank you. Yeah, because that was a negative 3. Very good. Okay, so there you are. We are ready to give you the directional derivative. okay, directional derivative of G at the 3 pi 4 negative pi half. You see the first part would be 0. It's a 0 times u1 plus a 0 times u2. They would disappear. So we get the last part, which is 3 radical 2 over 2 times u3. u3 is 3 over radical 14. Okay, that's it. So it's going to be equal to the 9 radical 2. 9 radical 2 over radical 14. Okay, if you want to simplify, radical 14 is radical 2 times 7. But that take you back again to this. Okay, you can use calculator just a little bit. Okay, so that gives you the final answer. Again, this must be a number. Some people they make a mistake at the end. They bring I, J, K. No, it's a number. Get the number right away. Okay. Any question? Oh, the last problem is easy problem, but you have to know it. Okay, it's application problems. Okay. Remember, we used the Cauchy-Schwarz inequality to show that the maximum value or the maximum rate of change of the directional derivative is the norm of the gradient vector, and this maximum can be received, can be attained in the direction of the gradient vector. You see, this is the one that we did. Please remind you for number 10. Are you done? See number 10, very important property of this directional derivative. Number 10. Number 10, the maximum values of the directional derivative in the direction of the u is always the norm of the gradient vector. Because the norm of the gradient vector is going to be a number at a given point. The point will be given to you. So this is going to be maximum rate of change. This is maximum rate of change. Rate of change. Now, in what direction you are going to get this maximum? In the direction of the gradient vector. Okay, it can be realized or attained. Okay, realized in the direction of the gradient vector. So this means the gradient one is going to be, you see this is one, it's just gradient vector. This is going to be something like we call it ABC. If you like. So you must know these two facts to be able to do this type of problems. So this is how this, I write it down, number 10, so you know that. So in number 10, you want to find, okay, you want to find the unit vector, find the unit vector. Unit vector u at the point P equal to 0, 0, 1, pointing in the direction, okay, in the direction which the function f of x, y, z equal to the x z plus e to the negative x squared plus y increases most rapidly. See? All this means is that vector is a gradient vector. And you have to normalize it because they ask for the unit vector. So answer would be, the solution is going to be, you have to find the, this is here, you have to find the gradient vector. You have to normalize it. If they didn't say unit vector, you don't have to normalize it. Okay, but in this case, we have to normalize it. So there you are, we have to find the gradient first. Okay, so the gradient is going to be a function of three variables, f sub x, f sub y, f sub z. So you have to do this one at the point P, which is equal to the 0, 0, 1. Then normalize it as a vector, then you that. So this is your function. Carefully differentiate it. Okay. So we go for the f sub x, focus on x. F of xz would be just z. Exponential function never change, e to the negative x squared plus y, and you have to multiply by u prime. If of the top respect to the x, it's a negative 2x. So it would be z minus 2x e to the negative x squared plus 1. Any question? But you have to find it at the given point. So let's do it at the point. So f sub x at the point is 0, 0, 1. x0, y0, z1, 1. That's it. Because this x is 0. So it's going to be 1 minus 2 times 0, which is going to be 1 minus 0, which is 1. That is f sub x. Question? F sub y. Partial derivative with respect to the y. Go back to the function again. This is your function. With respect to the y, there is no y here, so that would be 0. Exponential function never change. It's going to be 0. Plus exponential function is going to be the same thing. But you have to multiply by u prime. If top to top respect to the y. Top respect to the y would be just a 1. So that gives you e to the negative x squared plus 1. Okay. This is it, x squared, x squared plus y. So we'll find it at the, okay, at the number that we have. Okay. Not to lose that one. Okay, let's see. So if you want to find it at 0, 0, 1, x0, y0, y1. So that give you what? One of them are 0. So it's going to be e to the 0, which is going to be 1. Okay, so that gives us f of y. Okay, we need one more. With respect to the z. Again, the function, this is your function again. Okay, derivative with respect to the z would be just x, because the xz is the first one. And if you find it at 0, 0, 1, the result would be 0. Okay, so your gradient at this point is going to be what? 1, 1, 1, 0. That is going to be direction. But they ask for the unit vector. So you have to normalize it. Okay, you find the gradient, norm of the gradient, which is going to be 1 squared, 1 squared. Of course, this is not squared. That gives you 1 plus 1, which is 2. So the norm of the gradient would be radical 2. This is the maximum value. If they ask for the maximum rate of change, this would be maximum rate of change. And they ask for the direction. Direction is this. That they ask for the unit vector. So there you are. So the unit vector in the question is going to be this one. I like to put it here. Okay, so the unit vector is the gradient over the norm of the gradient. Okay, so the norm is radical 2. So it's going to be 1 over radical 2 times the gradient vector. So it's going to be 1 over radical 2. The gradient vector is 1, 1, 0. So that normal vector that you are looking for is this one. U equal to 1 over radical 2, 1 over radical 2, and 0. So that's the kind of application problem that we're going to have. Okay, so that's it. This is all the possible. Study this one carefully. You shouldn't have to be worried about it. Okay, for the test, but make sure you study your quiz. 4 questions from the quiz. The function would be given to you, ask for the domain, the range, identify the graph as we did it before. Then we give you a couple of limits to find. Okay, ordinary one, those substitution 1, 0, 0, 1. Then we give another question. We ask you to show that the limit does not exist. Different direction. Okay, that's a 1. Then you have a question. They ask for the continuity, where the function is continuous. The function can be ordinary function or can be a piecewise defined function. So these are going to be the one that was not on that review. But the rest is the one that we did today. Those numbers. Any question? You know that you can take the test at the APC starting tomorrow, or just come here and do it during the